over here, we find Sudhir is investing a certain amount of money in a bank because Sudhir was not a very shrewd businessman. So he has invested rupees 1 lakh in the bank, and the bank has given him a certain advantage. The bank told Sudhir that they will be willing to hike up the rate of interest from the first year to the second year if Sudhir keeps his money for 2 years. So the bank said for the first year, they would offer him 15%, and for the second year, by hiking it up, they would offer him 18%. So in this way, how can Sudhir find out what is the amount that he will receive at the end of 2 years? Let us try to calculate. Firstly, we apply the formula which we have for finding out the amount when interest is compounded. So A is equal to P into 1 plus R by 100 to the power of N. So in this case, N is 2, P is given to us as 1 lakh. But how can we place the value of R? We know that N is 2 and P is 1 lakh. But R is given by two particular values for 2 different years. For year 1, it is 15%. And for year 2, it is 18%. So as you can see, I can't put any one value because that would result in an incorrect amount. So which is the value that I will have to place? 15% or 18%? The answer is neither, because when the rates of interest are different for 2 different years, then this particular formula cannot be used. And that is true if many such different rates of interest are given to us. Let's say we have calculated, or we want to calculate, a given amount for n years. So in that case, if R differs for each of those n years, then this formula becomes inapplicable. So let us see how to approach the problem if the rates of interest are different. So let us calculate what will be the amount for the first year. That will be equal to A1 equals P1 multiplied by 1 plus R1 by 100. Now I know all these values. P1 is equal to 1 lakh. 1 plus R1 by 100, where R1 is equal to 15. So this is what I get. Now if I simplify this equation, I can write it as 1 lakh multiplied by 115 divided by 100. Now it's a simple matter of cancelling 2 zeros from the numerator and denominator. So I am left with 115 into 1000, which gives me rupees 1,15,000. So this is the amount of money that Sudhir receives from the bank at the end of the first year. So this amount of money, A1, will be the principal for the next year. So the principal for the second year will be equal to the amount for the first year, which is equal to 1,15,000. So we apply the same formula for finding out the amount at the end of second year. So that will be equal to A2 equal to P2 multiplied by 1 plus R2 by 100. So in this equation, it is a matter of simply putting the values which we already know. P2 is nothing but A1, which is equal to 1,15,000. And R2 has been given to us as 18%. That is the rate of interest offered by the bank to Sudhir in the second year. So we get this equation. Now again we simplify this equation and write 1,15,000 multiplied by 118 divided by 100. So I cancel the zeros again from the numerator and denominator, and this equation gives me a resulting value of rupees 1,35,700. So this is the amount earned by Sudhir at the end of 2 years. That is at the end of the second year, when the rates of interest are different. So now let us consider a general scenario. We found that at the end of first year, the principal for the second year was equal to the amount at the end of first year. Now for the second year, if we have to calculate the amount, we wrote P2 into 1 plus R2 by 100. Now P2 is nothing but A1. And what is A1? A1 is equal to P1 into 1 plus R1 by 100. That is the amount of money that was originally invested multiplied by 1 plus the rate for first year divided by 100. So this is the formula which we can replace for A1. So thus I replace the value of A1 with P1 into 1 plus R1 by 100. And this part of the formula remains as 1 plus R2 by 100. So we find that amount at the end of 2 years is given by the original sum invested, and then for each consecutive year calculating 1 plus R1 by 100, 1 plus R2 by 100, 1 plus R3 by 100 and so on. So let us say that there are n successive years. We will have to calculate this particular term for n such years, given that each year there is a different rate of interest. So I can generalize this and say A will be equal to P into 1 plus R1 by 100 into 1 plus R2 by 100 when n is equal to 2 years. So let's say that n is equal to 4 years. In that case, we will have the amount at the end of 4 years as P into 1 plus R1 by 100 into 1 plus R2 by 100 into 1 plus R3 by 100 into 1 plus R4 by 100.